When I very first got into networking, one of the first things that confused me a little bit was the concept of VLANs, and especially VLAN trunking. So for all of you beginners out there, this video is for you. I'm also not going to just cover the basics of VLANs without giving a few examples of what a traditional setup looks like first. So that way, you can compare and actually see what VLANs would equate to in a setup that would have existed in a time before VLANs were a thing. Or maybe a setup where managed switches aren't even used. Additionally, since a router will also be used to help show this concept, I figured I'd talk about layer 3 switches as well. I feel like I wouldn't be able to complete the entire picture without them, but that won't be until the very end, so if you didn't come here for that, don't worry, all of the VLAN stuff will be first. Either way though, this is going to be a slightly longer video, so buckle up because we're going for a ride. Alright, so let's go ahead and get started here. So if you take a look at the screen, what is it that you see over here? Well, nothing more than your typical average run-of-the-mill network. You have a router, an unmanaged switch, and some hosts connected to the switch. All of this is on the 192.168.1.0/24 network. We're not really going too far with this. We're going to build off of it, and that's what I meant at the beginning of the video when I said that I wanted to start with a traditional setup and then build off of it and give you a better idea when it comes to the concept of VLANs. So let's go ahead and really quickly, let's say that we wanted to extend this network. Well, that's simple enough. Let's just go grab a switch over here from the unmanaged switch pile. Let's drag another PC over, and let's connect this stuff together. So we'll connect this switch to the other switch. It's very, very basic elementary stuff here. And then connect this switch to this other PC. And now we have successfully extended this network right here. Let's go ahead and open up PC4 really quick. We'll give it an IP address on the same network, and we will carry on where we left off, the .52, so we'll give this .53, 24-bit subnet mask, and the default gateway 192.168.1.1, which, by the way, I didn't mention it at the beginning. It's not really relevant, but that would be the IP address for the gigabit 0/0 interface on the router right here. So now that we have that set up, let's ping out to the internet. We have reachability, and let's just try to ping, let's ping PC1 here. And we have reachability. Perfect. Instead of extending this network, let's say you wanted to add an additional network in a completely different broadcast domain. So let's go ahead and do that really quick. First thing I want to do, if I can right-click on this, that is remove this link. And now, obviously, these two switches are physically independent, and they're not linked by any type of cable. And let's go ahead and now put PC4 on the 172.16.1.0/24 network. So, all right, great. We have our two networks now. But what's the issue? Well, it's pretty obvious. Well, first of all, this network only has one computer connected to it, so that's pretty pointless. You don't need a network if it's just a single computer that isn't going to be accessing anything else. But just pretend there are multiple PCs connected to unmanaged switch 2 as well. So it's like, all right, well, we have this network, the 172.16.1.0/24 network. All of those PCs could communicate with each other, but we have no internet connectivity at that point, like we do over here on the 192.168.1.0/24 network. So what we could do is, well, we could add another router over here and connect it to unmanaged switch 2, but then we would have to give it its own separate internet connection, and then these two networks would both be, well, at least locally, completely disconnected from one another. And the reason I say locally is because they would technically be connected through the internet connection if we did add another router and then have that router connected to the internet. But as of right now, this is a pretty useless network. We do have our two networks, but completely disconnected. So what can we do to join these networks together? Well, just like when it comes to our internet connection, we need a router, a device that's capable of looking at the layer 3 header where the IP addresses are contained and making a forwarding decision based on that destination IP address. So since we already have a router right here, let's just go ahead and connect this unmanaged switch 2 up to one of the interfaces on this router. So we'll choose gigabit 0/1 and connect it over here to Ethernet 0 on the unmanaged switch. Let's go ahead and open up the console window really quick for the router and just configure that gigabit 0/1 interface. And of course we have to put our NAT statement in there. Oops, and then we have to, I'm not sure if that interface is shut down, but we want to bring it up if it is. And now let's take a look at this topology really quick. Now we have two separate networks, but both of them are connected at the router. So these two networks are connected together locally. And let's just double check. Well, not double check, we haven't even checked once yet. Let's check and see if PC4 can actually get out to the internet. And it can. Now, let's see if PC4 can ping one of these PCs over here on the 192.168.1.0 network. So we'll ping PC1. Perfect. So at this point, get a real good picture of this in your head, because I'm going to take this setup and I'm going to combine it with the two different networks, but into one switch and one switch only. Let's reconstruct this, and I'm going to show you what it would look like if you were using VLANs instead of separate switches to divide up your networks. Let's go ahead and remove this cable, and we'll disconnect this guy as well. And now here's the other thing. We have to get rid of this unmanaged switch because it's unmanaged, obviously, and it doesn't support VLAN, so we need to use a managed switch for this. Let's get rid of that guy. And scoot over here really quick. Pick up this managed switch. Drop it right over here. Scoot this back over. Alright, so at this point everything's looking pretty much the same as it was, or as it did before, because it's exactly the same. We have a switch connected to a router, and then we have our PCs hanging off of the switch. So there is one thing that's different, obviously, but you can't see it because it's a logical thing. Like I said, this isn't an unmanaged switch, this is a managed switch. So now we can log into this switch. Oh, and then let me scoot PC4 over here as well. And connect it there also. So let's bring over the console for manage switch 1. And let's create 2 VLANs. One VLAN that's going to represent the 192.168.1.0 network, or at least that broadcast domain, and then another one for the 172.16.1.0. I'll choose VLAN 10 for the 192.168 network, and I'll choose VLAN 20 for the 172.16 network. Okay, so at this point, all I've done is I've created 2 VLANs. I haven't assigned anything to these VLANs yet, and remember, just for reference purposes, let's bring back the old setup. Those VLANs, the VLANs 10 and 20, are representing 2 individual broadcast domains. So in the original setup, we have a broadcast domain right here, and we have a broadcast domain right here. So let's actually assign the interfaces we want to the corresponding VLANs. So we see that PC 1, 2, and 3 on the 192.168.1.0 network are connected to, I know it's a little bit hard to see now because they're overlapping, but gigabit 0/1, 0/2, and 0/3 on this managed switch. Let's go interface range, gigabit 0/1 through 3, switch port mode access, switch port access VLAN 10. Do show VLAN brief. And we see that VLAN 10 is active and ports 1, 2, and 3 are assigned to it. So at this point, what we've done is we have effectively taken this managed switch right here and now kind of broken a small chunk of it off into its own little mini virtual switch, if you will. That would contain these 3 hosts right here that were previously on this broadcast domain. Let's go ahead and do the same thing for PC4, which is connected to gigabit 1/0. So what we need to do is assign gigabit 1/0 to VLAN 20. So here we go. Our VLAN 10 once again, and then VLAN 20. So at this point, what's actually happening? Well, let's bring the old topology up again for reference purposes. One more time. Try to get this stuff. I don't know. I hope some of the stuff isn't going to be too small. I don't know if you're watching this on a phone or a computer or whatever, but anyways, let's drag this. Actually, Let's drag this way over here, and then just drag this over here. Boom. There we go. So I really hope that at this point, you're understanding where I'm going with this. These two switches, 1 and 2, the unmanaged ones in the previous topology, are now being essentially virtualized on this managed switch right here. So unmanaged switch 1, or should I say, we'll just call it broadcast domain 1. So everything coming off of the router's gigabit 0/0 interface in this topology would be in its own broadcast domain. And then everything coming off of gigabit 0/1 would also be in its own broadcast domain. So essentially, VLAN 10 on the managed switch over here is this broadcast domain. You saw that I went in there and I assigned gigabit 1, 2, and 3 to VLAN 10, this broadcast domain right here, and then gigabit 1/0 to VLAN 20, which would be this broadcast domain right here. So now we essentially have 2 switches in 1. So we need to get these up to the router so we have connectivity not only to the internet but also between hosts in these 2 networks if we want that. So let me bring the switch configuration back over here, and I'm going to start by taking gig 00 and I'm going to take the gigabit 00 interface and I'm going to put it in VLAN 10. So now at this point, VLAN 10, which encompasses all of this stuff down here, and the managed switch, its gig 00 interface, are all in the same broadcast domain. So at this point, looking back on the old topology, this is now pretty much the same minus everything that's coming off of the gig 0/1 interface. So at this point, with PC 1, 2, and 3, we should have reachability between PCs as well as reachability out to the internet. Perfect. But not PC4 yet. And why is that? Well, it's because, let's bring this up, and look, for anybody that's watching this that's like, oh, he's being so redundant at this point, I have to be. It's my job to do the best job possible, the best job that I can do to get this into other people's heads. So just bear with me. We're going to keep moving along, but I want to get these concepts in your minds and is solidified as much as I possibly can. So anyways, the reason PC4 doesn't have connectivity is because, well, like I just said, right now with gigabit 0/0 and then gigabit 0/1, 2, and 3 all on VLAN 10, we've essentially replicated just this setup right here with this managed switch. So even though gigabit 1/0 is in VLAN 20, keep in mind that's it's a virtual broadcast domain, if you will. Another way I like to think of VLANs is like a pocket for a subnet, if you will. So let's get PC4 connected up to the router the same way we did with VLAN 10. Let's just take another cable and just hook it up to gig 1/1, and then we'll just go over here to gig 0/1, which, remember, gig 0/1 on the router was previously assigned the IP address 172.16.1.1. And now as soon as we stick, and it's difficult to see now because these are side by side, as soon as we put gigabit 1/1, we assign that to VLAN 20, we are going to have full connectivity. So let's go ahead and do that really quick. Zip right over here back to PC4. We have reachability out to the internet. And then since I took that one cable off, let's just hook it back up really quick. So it was 00 to 00. So once again, now we basically have this whole setup right here. Take these side by side. These are the same. Logically, they're the same. Not physically, because you see that we had two separate broadcast domains, and we still do. And then instead of using those two switches, we created two VLANs, assigned the interfaces over here to those VLANs, and then ran individual cables from each VLAN to the router. And now we have an identical setup without the need for additional equipment. I mean, unless you needed the additional equipment. I understand switches have limited port density, and there are times when you will need additional switches, additional routers, depending on what's happening with your network. But like I said, in this very simple example, we're just going over the basics, and I don't want to really go past that too much. So you might actually be one of those people watching this video that you already know a thing or two about VLANs, and you're like, why did you hook up two separate cables? Like, what? How is, like, would you just hook up a cable for every single VLAN? So you add another VLAN, a VLAN 30 and a VLAN 40, and you have all these cables going from the switch to the router for each VLAN. I did it the dumb way on purpose, so I can show you the right way to do it. Let's get rid of these. Let's remove those. Actually, what I'll do is I'll just default interface gig 00. And then what was the other one? 1/1. Just want to make sure everything is the way I want it right now. So, all right. So as of right now, VLAN 10, just these three interfaces. VLAN 20, just this interface. And now I'm going to show you how we can connect all of these VLANs. And if you had many more, it doesn't matter. Obviously, I'm just trying to keep it light, so I'm just going with two. But how you can connect multiple VLANs with a single physical cable using 802.1q encapsulation. So we're going to trunk these VLANs to the router instead of connecting a cable, a physical cable per each VLAN. All right, so how does this work? Well, instead of having a physical cable connected to a switch port that is assigned to each VLAN going to the router, or it could even be another switch depending on what you're doing, we are going to encapsulate these frames with 802.1q tags. So instead of the frame looking normal when it traverses this physical medium, it's going to have an additional part to it. It's going to contain a tag. Well, once we get done with this configuration. But once we're done with it, what's going to happen is anything that is in VLAN 10 that goes up to the router is going to be tagged with 10. Anything that's coming from VLAN 20 to the router is going to be tagged with 20. Now, we need to configure this on both ends, obviously, so it will work. And it's also my understanding that the terminology here is also vendor specific to a certain extent. I think in the Cisco world, a trunk is what I'm talking about right now, using 802.1q, or you could use ISL, which is Cisco proprietary. I don't think anybody uses that anymore though, but yeah, trunk would be tagging VLANs. And with, I don't know if it's all other vendors. If it's not all of them, it's a lot of them. A trunk, I believe, in their lingo refers to link aggregation. And then what would be a trunk in the Cisco world would be, they would refer to that as a tagged port. So if this was not Cisco equipment, we wouldn't call this a trunk. We would call it a tagged port. But since we're in the Cisco world right now, we're going to be configuring a trunk. All right, so let's start on the managed switch side, and we got to tell it what to do. So again, we have the cable connected to gigabit 0/0 on the managed switch side. So let's go ahead and open up that interface. And the first thing we want to do is change the switch port mode to trunk. Actually, some of them you have to say switch port, trunk, and then you have to set the encapsulation. So we're going to say switch port trunk encapsulation .1q, and then now we can tell the switch that we want it to be a trunk interface instead of a regular access interface. So switch port mode trunk. And I don't really want to get into best practices too much right now because that's not what this video is about. But out of habit, I always set the allowed VLANs. So I'll just go switch port trunk allowed VLAN 10 and 20. I don't know if I can leave a space there. Okay. Do show, I believe it's interfaces trunk. There we go. Okay, so take a look at this output really quick. Now on gigabit 0/0, we have VLANs 10 and 20 allowed on the trunk, active, and in a forwarding state, and not pruned. That's a spanning tree thing. That's another thing this video is not about, so I'm not going to go into that. But at this point, at least on the managed switch side, this gigabit 0/0 interface is configured to carry traffic for both VLAN 10 right here and VLAN 20 over here. So let's open up the router really quick. And on the router side, it's going to be a little bit different because we're not dealing with trunk interfaces like we would on a switch. We are dealing with sub interfaces. It's pretty much the same thing. The way you configure it, however, is a little bit different. So this connects to gigabit 0/6 on the router. Let's go ahead and get into that interface. Do a no shut right now because otherwise I'll forget. And I'm going to exit back out of it because we're not configuring anything specifically on the actual physical interface, gigabit 0/6. We are going to create individual sub-interfaces. You accomplish that by going interface gigabit 0/6 dot and then Start with .10 to indicate VLAN 10. It doesn't have to match up, but it makes sense to match it up the best you can to what is what the encapsulation is going to be. So if you're encapsulating traffic for like VLAN 10, you'd want the sub interface to be VLAN 10. It's more organized that way, obviously. Switch port, or no, we don't. We don't do switch port. It's not a switch port. It's a routed port. All right, what am I doing? Get out of that. Encapsulation, .1Q, and then here's where we set the VLAN. 10. And then now we can set an IP address. So remember previously when gig 0/0 had the IP address 192.168.1.1 for this network right here, and gigabit 0/1 had the IP address 172.16.1.1 for this network over here. Now we're going to assign that IP address 192.168.1.1 to the sub-interface, which will be responsible for all VLAN 10 traffic. And then we have to put our NAT statement in there if we want the internet to work with this configuration. All right, so one down. Let's just test that really quick. We'll use PC1. And look at that. Now, of course, we have one more configuration step for PC4, so we're not going to have internet connectivity or connectivity to any of these hosts on this other network yet. So we'll do that next, and it's going to be the same thing that I just did for VLAN 10. Except the sub-interface will be .20 instead of .10. Encapsulation, .1Q, 20, and then IP address, 172.16.1.1, 24-bit subnet mask. Let's come back over here to PC4. Oh, we forgot our NAT statement, of course. Let's give that another go. And look at that. Let's try to contact a PC in the 192.168.1.0 network. Perfect. Perfect. There's no .53. And perfect. So at this point, do you see what I've done there? Is that starting to make sense? Or should I say, did that make sense? So we've taken this, got rid of the two cables, one cable, two switches, one switch. Exact same thing, logically, but condensed down to this right here instead. There's really not much more to it than that. I'll go ahead and let me drag over another managed switch. Remember at the very beginning, the very first thing I did was I extended the 192.168.1.0 network by just running another daisy chaining a switch, all in the same layer 2 broadcast domain. I'll just give you an example, or the same example, but how it would work now that we have our VLAN set up instead of each switch only being part of one broadcast domain at a time. So let's go ahead and connect this other managed switch, and Drag another PC over here. I'm just all willy-nilly with the interfaces at this point. And so let's say that we want to go back to the original. Let's say we wanted to add another PC to the 172.16.1.0 network, which, remember, is assigned to VLAN 20. On our new design, we'll start off by logging into the Manage Switch 1 once again. And we have this cable connected to its gig 1/1 interface. So just like I did before, switch port trunk encapsulation .1Q. Switch port mode trunk. Switch port trunk allowed VLAN 20. Let's swing over to Manage Switch 2. Do the same thing. Switch port trunk encapsulation .1Q. Switch port mode trunk. We also have to create our VLAN 20 as well. Go back to gig 0/0. Switch port trunk allowed VLAN 20. Let's open up PC5. Give it an IP address on the 172.16.1.0 network. We'll go to 51. And 172.16.1.1 for our default gateway. See if we have connectivity. I mean, we're never going to have connectivity if I can't get my typing under control. It might take a moment for the switch to... oh, you know what else it probably is? Video's not about this either, but really quick. Oh, well, first of all, there's another thing. We have to put gigabit 0/1 in, or we have to assign it to VLAN 20 on Manage Switch 2. So interface gig 0/1, switch port, mode access, switch port access, VLAN 20. And then the thing that I thought of before this was spanning tree host. Where's its mode? Switch port host. There's two different ways. Oh, the other one would be spanning tree mode port fast, I think. Or just spanning tree port fast. It doesn't matter. Yeah, spanning tree port fast. And that's just indicating that the endpoint, whatever's connected to this switch, is not another switch. It's a host, so that way spanning tree isn't going to go through, you know, if it's a classic spanning tree, the 50 seconds of the, you know, listening, learning, and all that stuff. All right, so at this point we have gigabit 0/1 on Managed Switch 2 in VLAN 20. This is a trunk interface. We set it up on both ends as a trunk interface, only allowing traffic for VLAN 20 as of right now. And right now on PC5 we should have connectivity with the rest of the network. So we have connectivity with the network, or the internet. Let's ping PC4 over here, which is 172.16.1.50. Perfect. And let's ping one of these guys in VLAN 10. And there we go. So when we ping a PC in VLAN 10, well, let's go back here. Originally, the traffic would go up, be forwarded at layer 2 through this switch to the router, and the router would route it down here, and then through the unmanaged switch to PC1. Now what's happening is, where do we initiate that from? PC5? Yep. So the traffic is being forwarded to this managed switch. It's being encapsulated right here with using .1Q. So a tag is applied to it, indicating that it's VLAN 20 traffic. It's being received by the managed switch, which is seeing that, throwing it on VLAN 20. And then it's being encapsulated once again, going up to the router, because this is also a trunk interface. So the managed switch is throwing that tag of 20 on there. It hits the router. The router receives it, lands on its gig 0/6.20 subinterface, remember? And then re-encapsulates it with a tag of 10, because we're going down to, we were pinging PC1, re-encapsulates it with a tag of 10, sends it out of its logical gigabit 0/6.10 interface, comes back down to the same switch, but now on VLAN 10, and then it's forwarded out of gigabit 0/1 untagged to PC1. And pretty much the same thing happens in reverse. So yeah, if you wanted to add an additional VLAN, so we drug over another PC, and say you wanted this to be on VLAN VLAN 10, then go, connect it up, go into this managed switch here, managed switch 2, assign gig 02 to VLAN 10, and then allow VLAN 10 on the trunk interface connecting managed switch 2 and managed switch 1 together. It's simple as that. All right, so last but not least, I want to touch on layer 3 switching just really quick. I just feel like the picture, the big picture is not complete if I don't at least touch on this for a second. So for those of you that are not familiar with layer 3 switching, this icon indicates a layer 3 switch. I just named them managed switch 1 and managed switch 2 because I wanted to just look at them as plain old managed switches, managed layer 2 switches, that is. I didn't want to bring any of the layer 3 aspects into this just yet. But these are also layer 3 switches, and what that means is you're basically just taking a router and you're just sticking it inside the switch. Now, you might be wondering, well, then I don't need a router at all anymore. I can just connect my internet right to the switch, right, and be good? Well, not necessarily. Let me explain. Right now, we are doing all of our inter-VLAN routing on the router. The same way we were at the very beginning, except this was not virtualized in any way. It was all physical stuff going to the router. Same exact thing, even though we're trunking our VLANs up to the router now. The router is still doing all of the routing in between, well, in our case, VLAN 10 and VLAN 20. Sometimes routers are less, well, a lot of times, especially older routers, are a lot less efficient since everything on the router is done in software. On a switch, everything is done, it's done in hardware because they use something called ASICs. And so you can route at line speed on a switch. So if you have a gigabit switch and you're using it for routing, you're going to route at 1 gigabit per second. If it's a 10 gigabit per second switch and it's layer 3 and you're routing 10 gigabits per second, there are still quite a few routers out there on the market, quite a few routers that people are currently using that, let's just say it has a single or multiple gigabit interfaces, and you only get like, you top out at 250 or 300 megabits per second. because the router is just not as good, since it's doing it in software, as something like a layer 3 switch that uses those ASICs. Now, as far as just getting rid of the router altogether and using a layer 3 switch, well, that's where the router does shine, in the area of features. The router might be a little slower. The router has all the features that you're going to need. Like if you have an IPv4 connection, you're going to need to use NAT. And I don't know if there are any layer 3 switches that support NAT. Another thing would be firewall. If you need security in between VLANs, you could use CBAC or Cisco zone-based firewall on the router, or whatever other vendors have to offer if it's a different vendor. But routing on a switch does come in handy is for performance, and if you don't need security in between VLANs, maybe you just have multiple VLANs for organization or something like that, and so what you're going to do is you're going to use the switch to do all of the inner VLAN routing, and the router that's going to go out to, well, the internet, or maybe if you have a DMZ or something like that. And even if you need a little bit of security in between VLANs, you can still use, it's a bit of a pain in the butt to deal with compared to a firewall that is stateful, but you can use access control lists. But anyways, let me just give you one last example using this switch as a layer 3 switch instead of instead of the routing in between VLANs 10 and 20 occurring on the router. Let me pull over manage switch 1 really quick. Let me default gigabit 0/0. You're going to figure out why I'm doing this in a second. The reason I am defaulting gig 0/0 is because I am going to have a separate interface for these VLANs, or for the routing of the VLAN traffic to the router for internet access. And I'm going to create something on the managed switch 1 called a switch virtual interface. Well, actually 2 of them, and that is what is going to actually serve as our new default gateway for these 2 VLANs that we have configured. So remember a while ago when we created VLAN 10 and 20? Almost the same thing, except we're going to type in interface VLAN 10, and then we can assign the layer 3 address here. So 192.168.1.1. Interface VLAN 20. Sorry about the log messages popping up. See, interface VLAN 20. IP address 172.16.1. So now instead of these IP addresses residing up here on the router, which would mean that if we had PC4 communicating with a PC on this network, or one of these PCs communicating with PC4, remember previously the traffic would be forwarded to the router and then routed back down to the switch, which this model right here would be called, if you've ever heard of router on a stick, that's why they call it router on a stick. You just have a router hanging off of a switch with a cable. Sometimes you'd, I don't know how common it is anymore, but Cisco does make routers with just one interface. And if you don't really know your stuff, you look at that and it's like, how am I supposed to use a router with one interface? That doesn't make sense. But once you learn this stuff, then you realize how it's completely usable, because you have your VLANs on your switch, and then you're trunking the VLANs, to and from the router. But anyways, the router is no longer doing that job. The switch is now routing traffic between VLANs. So let's just see how that works really quick. PC4, we're on PC4 right here. Let's just ping well, the last one we pinged before, PC2, or I'm sorry, PC3. And there you go. Now, I think I already said last but not least, this is going to be the last thing, I promise. We want to configure this link between the router and the managed switch. Since the managed switch is now doing the inter-VLAN routing, I mean, we could still have our link trunk the way that it was, but it's not an efficient way to do it. And the routing would be inefficient if we did it that way. We want to have a separate network and utilize the routing table in the switch to send all traffic, or we'll create a default route and send it across this link to whatever IP address we use on the other end of this link that is connected to the router. Let me show you what I mean by that really quick. Because right now, obviously, we have no internet connectivity. Let's see, destination host unreachable. So let's go back over to the managed switch, open up gig 0/0. No switch port. Now, this might be different depending on what the application is and how the network's set up. Sometimes you actually will have a trunk for different VLANs, even if you are routing on the layer 3 switch, but I'm not going to touch anywhere near close to anything like that right now. As a matter of fact, I think I've gone way too far as it is. But right now, we're just going to make this a layer 3 link. Meaning it's just a single layer 3 interface, like an interface on a router that you can assign an IP address directly to. So once I issued that no switch port command, that means that I can assign an IP address directly to the gig 0/0 interface on managed switch 1, just like I would a router. I'll just give it the IP address 10.0.0.2. Do a /30. Don't worry about the subnet mask. If you're not familiar with subnetting, that's another topic for another time. No shut should be up as is. And then on the router side, I'm going to give the router's interface gig 0/6. An IP address of 10.0.0.1. But by doing this, we are greatly increasing the complexity of our setup, because now that we've brought routing, or additional routing, because the only routing we had before was just between the router and the internet, and the router and these two VLANs, VLANs 10 and 20, now we've introduced additional routing into the mix. Let me just make sure I can ping the other end of that link. Remember 10.0.0.2 on managed switch 1's gig 0/0 interface. All right, so we have reachability. So now we have this link right now. It's a layer 3 link, and it is on the 10.0.0.0/30 network. And now we need to configure some routing on the switch and the router in order to get this to work correctly. Because as of right now, let me just go back to PC4. We still don't have any connectivity to the internet. So let's go ahead and go back to manage switch 1. Now we have to tell it for our default route, we want to send that traffic to 10.0.0.1. There's the route. Now, it's still not going to work. But you notice that we don't have the destination host unreachable message anymore. Well, the reason for that is because we were getting that message from the managed switch, and now the managed switch is actually forwarding this to the router. And this is another reason I said that this is going to increase the complexity of the configuration a bit, because now we have all this other routing stuff we have to do. I mean, it's not a huge deal, but if somebody new in the field, definitely might be a little bit more into it than they prefer to be at that point. So to resolve this, we have to go back over to the router, and we need to add specific routes to the subnets for VLAN 10 and VLAN 20. So IP route 192.168.1.0. And 10.0.0.2 would be the next hop. And then let me just bring that up again and just switch this out for VLAN 20's network, 172.16. Let me just do a test ping to 172.16.1.1. Remember the SVI for those VLANs on managed switch 1. And the SVI for VLAN 10. Now I'm getting my VLANs mixed up. Yeah, I think the 192.168.1.0 is VLAN 10. Oh, what am I? I'm saying 10 while I'm typing. I meant to ping 192.168.1.1. And we have connectivity. We should be all set now. Let's go back over to PC4. Oh, just like before. Forgot the NAT statement once again. Of course, interface 0/6 IP NAT inside. Get that pinging again. PC4, perfect. Going out to the internet, getting a response. Everything's working. Open up PC1. Let's do the same thing. And there you go. All right, everyone. I'm going to close this video out here. Like I was saying, I already went way above what it was that I originally intended to do. But after a while, I figured, well, if I can cram this one more thing in there, you know what I mean? I thought maybe it would be a help. So hopefully this helped increase your knowledge or give you a firmer understanding, or an understanding period, of this type of stuff. I know, like I said at the very beginning of the video, that you know, when I first got into networking myself, VLANs confused me a little bit, but especially VLAN trunking, for sure. And then layer 3 switching, and then after I thought I had all of that stuff down, I got into redundancy, and then that's what, mind blown. Like, networking gets deep. It really does. It gets super deep, super complicated. And that's why those people out there that have their CCIE, some people call it their PhD in networking. It goes deep, super deep, especially when you get into stuff like routing protocols, but then not just routing protocols, underlay networks and overlay networks and BGP and VXLAN and yeah, just all sorts of stuff where you're tunneling traffic, you know, to different endpoints and stuff like that. It gets wild. But hey, if you're first starting out and you watch this video, first of all, congratulations and thank you so much for watching the whole thing. And you're doing great. You're going to get this. This is a great first step to, you know, understanding these fundamental things. And then once you get this stuff down, you're gonna take off, and you know, you're off to the races with it. So like I say at the end of every single one of my videos, if you have any questions, you can leave a comment in the comment section or email me. My email is rob@rmtechcentral.com. Sometimes it takes me a little while to get back. or to respond to questions, but I do my best to get back to everybody in a reasonable time frame. But yeah, with that said, really hope you learned something. Reach out with any questions. If you like the video, like it, subscribe to the channel, please, if you haven't already. That really helps us out. And thanks for watching. I'll see you on the next one.